In this last section on the mole, we will be learning about molecular formulas. Recall from our last screencast that the empirical formula is the lowest whole number ratio of atoms in a compound. The molecular formula is the actual number of atoms in a compound. Sometimes your molecular formula and your empirical formula are the same. For example, in water, both formulas are H2O. But at other times, they're different. For example, glucose's empirical formula is CH2O, while the molecular formula is C6H12O6. Please don't take the time to copy this table down. A lot of you already did in the last screencast. Just make sure you understand that the empirical formula is the lowest whole number ratio of atoms, while the molecular formula is the actual number of atoms in a compound. There are two different ways to approach solving molecular formula problems. This problem demonstrates the easiest way. For example, caffeine has an empirical formula of C4H5ON2 and a molar mass of 194.19 grams per mole. What is the molecular formula of the caffeine? The reason that this is the simpler problem is because you are given the empirical formula in the problem. So you don't have to find that first. What we're going to do is find the molar mass of our empirical formula. So I have 4 carbons. So for carbon, I will take 4 times 12, and I get 48. I have 5 hydrogens. 5 times 1.0 equals 5.0. I have 1 oxygen. 1 times 16.0 equals 16.0. And I have 2 nitrogens. 2 times 14.0 equals 28.0. Next, I add those numbers up, and I get 97.0. I'm told in the problem that I have a molar mass of 194.19 grams per mole for my molecular formula. So what I need to do is take that molar mass, 194.19, and I'll divide it by my molar mass for the empirical formula, 97. And when I do that, I get 2. This tells me that I have to multiply every subscript for my empirical formula by 2. So my molecular formula is C8H10O2 and 4. This is the more challenging problem, and it's because we do not have the empirical formula given to us. To find the empirical formula, we have to go back to what we learned in the last screencast. An unknown compound is found to contain 40% carbon, 6.7% hydrogen, and 53.3% oxygen, with a molecular mass of 60 grams per mole. What is the molecular formula of the compound? Recall from the last section, when we want to find the empirical formula, we take our percent and treat it like a mass. So for carbon, I'm going to change my 40% to 40 grams, and then I'll divide it by the atomic mass of carbon, which is 12. So 40 divided by 12 is 3.33. Likewise for hydrogen, I'm going to take 6.7 grams times 1 mole over the molar mass of hydrogen, which is 1, and I get 6.7. And then for oxygen, I'm going to take 53.3 times 1 mole over the atomic mass of oxygen, which is 16. 53.3 divided by 16 is 3.33. Our next step was to divide by the smallest answer. Between those 3 answers, the smallest number is 3.33. So I divide every answer by 3.33. 3.33 divided by 3.33 is 1. 6.7 divided by 3.33 is 2. And 3.33 divided by 3.33 is 1. So this tells me that my empirical formula is CH2O. Now that I know my empirical formula, I can go back and follow the steps from the previous practice problem. I'm going to start by finding the molar mass of CH2O. So I have 1 carbon at a mass of 12. 1 times 12 is 12. I have 2 hydrogens at a mass of 1. 2 times 1 is 2. And I have 1 oxygen at a mass of 16. So 1 times 16 is 16. And when I add these numbers up, I get a total mass of 30. Next, I go back to my problem and use the molar mass from the problem, which is 60 grams. So I'm going to take 60, divided my molar mass that I just calculated of 30. 60 divided by 30 is 2. This tells me I have to multiply each subscript in my empirical formula by 2. So my final answer is C2H4O2. At the end of your notes, copy down the question for these two practice problems, and then show your work to find the answer. You can submit a digital copy of your notes on Schoology or a handwritten copy of your notes to Mrs. Benke.